Here we're going to look at question 32 of the ENGAA 2018 paper. In this question, we're told we have a ball moving up a slope in a straight line at a constant speed. Then we're given a series of 6 statements and asked which statement must be correct. Now, looking at all of these statements, we see that they're all about forces, so the best thing to do is probably to label the forces acting on our ball on a diagram. Here I've labelled the forces on a diagram, then I've blown it up over here so that we can see the forces a bit more clearly and try and compare them a bit more accurately as well. It's also worth noting that I've resolved the weight into the component perpendicular to the slope and parallel to the slope. Now, the reason I've done this is because perpendicular to the slope, this component of the weight shall be in the same direction as the contact force, and the parallel component should be parallel to the driving force and our frictional force. Now, we know there must be a driving force as well because the ball is moving up with a constant speed. So if there wasn't any driving force, then the only component acting on it would be the weight and some frictional force perhaps. And therefore it would be moving down the slope. So we know we've got a driving force and the frictional force we can assume is there. And as well as that, it's also mentioned in some of the later parts of the question. Let's go ahead and look at our first statement, statement A, which says that all of the forces are equal in magnitude. Let's go ahead and look at our diagram and try and compare the forces in the direction perpendicular to the surface. So that is the contact force and the component of our weight coming down perpendicular to the surface. Now, we know that the ball isn't accelerating in this direction at all because it's flat on the surface. If it was, then it'd be moving off or it'd be moving into the surface. So our contact force and the component of our weight, which is perpendicular to the surface, must be equal to one another. Since these two are equal, then the weight cannot be equal to the contact force, since the component of weight perpendicular to the surface is going to be smaller than this. So our first statement is going to be false. It's worth noting as well that we could have compared the forces in the direction parallel to the surface, since the driving force must be equal to the parallel component of the weight and the friction, since it's going to be moving at a constant speed. So since no acceleration, the resultant force in this direction has to be 0, and therefore the driving force is not equal to the magnitude of the friction nor of the weight. It's equal to a combination of the two. If we go ahead and look at B, we can straight away see that this is not necessarily true. Since this question doesn't state that we don't have a frictional force, then if we do have a frictional force, then this certainly isn't true. We could, however, just not have a frictional force at all, in which case the driving force would be equal to the magnitude of the parallel component of weight. Now, this would be a perfectly reasonable system. It just doesn't have to be true, and the statement asks which must be correct. So B is also false. So let's go ahead and look at statement C, which states that the force of friction is equal to the driving force. Now, we can see from our diagram that this isn't true, since the driving force is going to be equal to the force of friction plus the component of the weight which is parallel to the surface. Now, therefore, C is also going to be false. If we look at statement D, it says that the weight is in the opposite direction to the contact force. Now, we know that the weight acts straight downwards because gravity acts straight downwards. Gravity isn't going to act in the direction of the slope. It wouldn't really make sense. Otherwise, nothing would ever roll down a slope. It would just sit there, since there'd be no component of weight parallel to the slope at all. There is, however, a perpendicular component of the weight, which is in the same direction as the contact force, but that's not what statement D is saying, so it's false as well. Let's look at statement E, which states that there is no air resistance on the mass. So there might be no air resistance on the mass, in which case our frictional force would just be due to friction from the surface. But if there was air resistance, then this frictional force would include the air resistance as well. So there could be air resistance, which would be included in this force, or there could not be. It's one of the ones which could be true, but is not necessarily true. So it's also going to be false. Finally, let's look at statement F, which states that there is no resultant force on the mass. So when we look at our particle, we know that it's moving in a constant speed parallel to the slope, and it's not accelerating at all perpendicular to the slope. So there's no acceleration on it at all. It's not changing directions, it's moving in a straight line. So yes, it's true, there must be no resultant force on the mass. Therefore, the correct statement is F.